Welcome to logarithms. Alright, so take the logarithm here. It says evaluate what power base 2 of 8. State your answer as a logarithm and then evaluate it. So we know we can call this a log base 2 of 8 equals what? The x. We can rewrite it. 2 to the x power equals 8. And then we know 2 to the x power equals 2 to the third. Same basis, set the exponents equal, and our answer is 3. If I go on to the same thing here in part B, you've got log base 5 of 625 equals what? It's your x. So 5 to the x power equals 625. So 5 to the x power equals, and we've done this one before, 5 to the 4th power. So my answer is 4. Just a little review of the last lesson. Okay, so now let's get into some logarithms. Alright, so we got an exploratory challenge. It says Autumn, take a look here, is starting up a new club. 8 members, including herself. She wants to assign everybody a secret code made out of A's and B's, okay, an ID code. So, for example, her ID code is going to be AA. Using A's and B's, can Autumn assign each club member a unique 2-character ID using only A's and B's, and then justify your answer. So, I will take care of the next one. Let's say I give Chris now, can't be the same, so let's say Chris is A and then a B. That's her code. I want you to finish filling out the chart the best you can and come up with an answer to this question. So pause the video for a sec and we'll talk about it. Okay, I hope you came up with also a B and an A next, or a B and a B next. But then, from that point on, plain and simple, there is not enough codes. You can only make 4 codes out of 2 digits. So 2 digits, okay, can only generate 4 codes. 1 digit only generates 1 code. We're going to start looking at that as we go along here. So, next it says, using A's and B's, how many characters would you need to assign each club member a unique ID code? And then justify your answer with that, as we're taking a look using the table above. So, I'm going to go back up here, I'll change color, and let's see here. Give it a try here, see if you can explore it again. Pause the video, and then come on back and we'll talk about it. Okay, so if we try 3 codes, you should be alright, because if I go back here and I go like this and say, okay, that's A, and A. And then this one is A, and B. And then A, B, and A. A, B, and B. Those are the same 4 I just had, except I put an A in front of it, right? Now I could do the same thing again. I can have B, A, and A if I take the same 2. And I could have B, A, and B. I could have B, B, and A. And I can have B, B, and B. So the bottom line is 3 digits will give me 8 unique codes. Okay, and we just proved it up above. Alright, so it says, when club grew to 16 members, Autumn started noticing a pattern for A's and B's. 2 people could be given a secret ID code with 1 letter, so 1 A or B. 4 people with 2 letters, so we got those combos. Then we just did 3 people, or 8 people with 3 letters, all those combinations. So what do you think is going to happen here? Well, if I need 16 people, a couple ways of looking at it. If I look at exponentially, 2 to the 1st power gives me 2. 2 squared gave me 4. 2 cubed gave me 8. So 2 to the 4th here would give me 16. So 4 letters would do it. But there is another way of looking at it, which is tied right in exponential. It's the inverse, which we will be talking about, which is logs. I could look at this as a log base 2 of 16 equals what? And that would be your 2 to the x, which we just talked about, equals 16. So we know the answer will turn out to be 4 when you do this, 2 to the 4th, okay? So 4 comes out of it. So logarithms tie directly into this process that we're going to look at. Okay, we're going to fill out the chart with these 16 on the next page. I want you to fill this out. So if Autumn starts off 4 codes, A, and I would keep this logically or you're going to lose yourself. So then A, B, then A, B, and A, B. I want you to pause the video and go finish it yourself, and then I'll finish it too. Okay, so how did you do on all this? Well, hopefully it wasn't too hard to fill out. It's kind of tedious and a pain in the neck. Now, here's a quick question. Which ones does Mr. O like the best? Pause and think about it for a second. Oh, I got 2. I got Merkel here, because it's ba, 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 ba. Or, when you're losing it totally, I got Mia. Okay, a little humor there in between. Forget about it. All right, let's move on. So, what type of pattern, it says describing words, could it be? And yes, I know you could say it's an exponential, and we can go with that as far as it's going. But we can also do logarithms. So we can do log base 2 of 2 equals 1. Log base 2 of 4 means 2 digits. Look at the 2. Log base 2 of 8 was equal to 3 letters, 3-digit codes. And log 2 of 16 gave me 4. So that's the pattern we want to look at and connect it to logs versus exponential, which is a direct relationship to this. So let's look at some more and keep this pattern thing going. Alright, so in the previous problem we talked about the letters, like digits. Hey, let's see here. A and B were digits. A 4-digit ID in Autumn's Club could generate 4-letter arrangements of A's and B's. And the only digits were A's and B's, though. When Autumn's Club grew to include more than 16 people, she will need 5 digits to assign the ID code for each member. What's the maximum number of people she could do? Switching this and explain your reasoning. So, we were last up to log base 2 of 16 for 4 digits, right? Could generate the 16 that we needed. So, how do I do this? Log base 2 of what equals for 5 digits? What is it going to go to? Well, this is the mystery now. We're going to plug an x in there instead of trying to figure out 5 digits. So if I use my problem, it's 2 to the 5th power equals x. Remember, we take this base here, raised to this exponent equals this on the other side. So what is 2 to the 5th? Nice and easy, 32. So she could now have up to 32 club members to have solve with 5 digits using just A's and B's. They ask, if Autumn has 256 members in her club, how many digits would be needed? So we got to go even bigger than that. So that's a log. We know we're going by 2's every time, but we know it's going to be 256, and now we want to know how many digits, so this kind of correlates directly back what we did before. Set up your problem, 2 to the x equals 256, then you got to figure out how many 256s we got there. So 2 to the x, oops, my bad, 2 raised to the x equals 2 raised to the 8th power. Therefore, she would need 8 digits. Alright, see how we're applying this one way or another, whether you're looking for the number of digits, or if you're looking at how much a certain number of digits will give you in code possibilities. Alright, and our final one here that we want to look at today is 1,000 people who were given unique identifiers of 0, 1, 2, 3, all the way up to 9. How many digits would be needed to make an ID number of that? Now, there's a couple ways you guys can look at this. Obviously, I could start off and saying, oh, I got 0, 0, 0. Then I got 0, 0, 1, and 0, 0, 2, and 0, 0, 3, and so on, all the way up to 999, which would give you 1,000 different combinations to allow you to do this. You also could look at it this. I've got log 10 digits here, so base 10, and I want 1,000 combos. How many digits would I need? I could set up my problem that way. So that means I got 10 raised to the x equals 1,000. And we know 1,000 is equal to 10 times 10 is 100 times 10 is 1,000. So that's 10 to the third. So the bottom line, 3 digits, which verifies what we just did by hand here, okay? So logarithms will allow you to do this. Notice this is on, because we're no longer talking just 2 letters, A or B. We're now talking all the digits, 0 through 9. My log base here changed to a 10, of which when it is log base 10, we generally don't even write that. We just say, hey, we got the log of 1,000. It's understood to be a base 10, and we're going to be talking about that in the future, 2 equals x, and of which you could use a calculator right away when it's log base 10, and it will tell you on that too. All right, so that's a pretty good amount of stuff here on the first day. We're going to take a second day of this and apply it a little bit more, but I'll see you in the class to get things rolling on these basics so we can keep those skills going. And if you don't like it, remember, go back and you can always talk to Mia.